Okay, so now this is the last section about factoring, which is probably your greatest day. So first, we multiplied special products like this earlier, right? What does it equal when you go y plus 4 times y minus 4? I mean, even if you don't remember the formula for doing this, FOIL it, right? What do you get if you FOIL y plus 4 times y minus 4? First, you do the y times y, you get y squared. Y times negative 4? Y, 4 times y, the inner, plus 4y. And then 4 times negative 4? Minus 16. So this whole thing, the negative 4y cancels with positive 4y. This is y squared minus 16. Remember, the formula said that it would be a squared minus b squared. So what is this one going to be without foiling it? X plus 3 times x minus 3 is x squared minus 9. Done. So that was a special product that we had from earlier, I think 9.3. Okay, well that leads to a factoring pattern that we use, which is called difference of squares, right? Difference of squares, which basically just says then we should be able to go backwards if we have something that looks like it was made by multiplying the special product, then you just go backwards. So difference is because it's a subtract, and it's two things that are being squared, so it's difference of squares. I think the book calls it the difference of two squares. So the formula is, I mean, this is the reverse of the formula we used for the special product, right? A plus b times a minus b is a squared minus b squared. So a squared minus b squared is a plus b times a minus b. So usually, if you get a difference of squares, first thing you notice is there's only two terms, right? So it can't be any of that kind of factoring that we did that required three terms. Quadratic trinomial, it's only two terms. I mean, it could be with just two terms that might be greatest common factor, but it can't be any of those quadratic trinomial things. The next thing you try to notice is, do you see a lot of perfect squares going on? And like 25, that's a perfect square. 49, yep. That's a perfect square. Okay, well this is just kind of giving you the clue. It's going to be a difference in squares. I mean, x squared is actually already written as a square. And what number squared equals 4? 2. So if you need to, you don't have to. You could write it like x squared minus 2 squared, and now it completely fits the pattern, right? So it should be x plus 2 times x minus 2. Yeah. What's that? The difference of two squares? Okay. So what is being squared in this term here? It's not 25m, right? The 25 is the perfect square. So you would have to like put that in parentheses as 5m squared, properties of exponents, says that's right. So now we've got something squared for the first term. And 49 is a perfect square. That's 7 squared. So, right, that fits the pattern now exactly, right? Something squared minus something squared. So this should be 5m plus 7, 5m minus 7. Right? Difference in squares. Just a minute. I always forget. I forget about the ones that I'm doing this for, that I need to do this for. That's all. The two black stuff in there. Okay. Sure. Okay. So try to factor that one. Right. You don't need to show an intermediate step, but if you do, that's okay too. Whatever helps you to. Does it look like the difference of squares? Yes. Because 25 is a perfect square. Again, some of these factoring patterns, I mean, it kind of depends on you recognizing a perfect square when you see it. Right? What is this one? X plus 5 times x minus 5. Right? If you wrote it like this, x minus 5 times x plus 5, it's okay. You can switch the order of multiplication. That's okay. So don't get hung up on that one point. Yeah. X squared minus 5 squared. Okay. If you wanted to write it like a difference of squares first, you could have wrote it as x squared minus 5 squared. Again, you know, if you see, yeah. By the formula, it's always one positive, one negative. Okay. And I mean, you could always show that, just spoil it, and see if you get back there. So, Felicity's asking, this is a good question, because somebody's going to do this. What if it was x squared plus 25? And here's the answer. Can't be factored. If it's not a difference of squares, we don't have a formula for it. Doesn't factor at all. It has to be a minus, right? So we don't have a formula for the sum of squares, just for the difference of squares. Right? It's not factorable. In fact, that's going to come up. That's going to come up when we get ready. That's if you get an expression and it's not factorable, it's called a prime polynomial. It can't be factored. Yeah. Yeah, I mean, I saw that on the worksheet. It was like they had one in the whole worksheet that was x squared minus 4, which we actually did on the previous slide, right? So you could think of it like this. You could say, what are the factors of negative 4 that add up to 0? Because there is no x term in the middle. That's like saying x squared plus 0x minus 4. And then use that same logic. What's the factors of the last number that add up to the middle number? And you would end up with, what are the factors of negative 4 that add up to 0? 2 and negative 2. So, okay, that's x plus 2 and x minus 2. So, yeah, that's good if you saw that. Got some different colors going on today. All right, try that one. Get back to blue. Right, does it look like a difference in squares? Probably. Is 36 a perfect square? Yeah, so it probably is. I mean, if you're looking at just two terms and you wonder whether it's a difference of squares, but you don't recognize your perfect squares, remember, you could just make a table of them in the calculator. Go at y equals, put x squared, and then you can look at them all at one time. So let me show the intermediate step here, right? What is it that's being squared in the second term? It's actually 6y, right? 6y squared. Okay, so now what does the difference of squares formula say that should be our factor? X plus 6y, x minus 6y. Yeah. I didn't hear you. Yeah, I can't really get much. I mean, you could have had like 49x squared minus 36y squared. Okay, you know, that's about it. I mean, if you see this as not complicated, that's a good thing. For some, it is complicated. Okay, so we had factoring patterns for this too, right? When you had like n plus 6 squared, right? The formula was something like this. It should be a squared, a plus b, in parentheses squared, is a squared plus 2ab plus b squared, right? Which means it's the first thing squared, the last term squared, and then twice the inner product, 2 times ab. So in this problem right here, it would be n squared plus 2 times n times 6 plus 6 squared, which is n squared plus 12n plus 36, right? So how about this one here? The first term squared plus 2 times, the 2 is part of the formula, 3x times 2 plus the last number squared, 2 squared. Simplify. 9x squared plus 2 times 3 times 2, 12x plus 4. Now, you could have gotten that without remembering the formula. You could have just said n plus 6 times n plus 6, and you would have got the same thing. You could have just said 3x plus 2 times 3x plus 2. No. I mean, you could FOIL them. Just FOIL them, and you get it. But the point of that is, that's what we did earlier. Now we want to go backwards from that. We want to go, what happens if you're given something that looks like that? How can we go directly to that as the factoring? And this one is not quite as obvious as the difference of squares is. But what you have to look at here, right, is that you notice that the first term, it's a trinomial, first of all, so it's not a difference of squares. The first term looks like a perfect square. The last term looks like a perfect square. So this should be, you know, what is it that's being squared in this first term? It's 3x. Right? What is it being squared in the last term? It's 2. So why don't we try 3x plus 2 squared. Okay, what happens if I FOIL that? I would get 3x times 3x is 9x squared. 3x times 2 is 6x. And then I would get it one more time. 2 times 3x, I would get 12x. And then I would get 2 times 2, which is 4. So it works. Now, look at these two now. What's the difference between the second one and the first one? It's a negative. So what does that tell you is probably going on? It's probably the 3x minus 2. That's why you get the negative, because it's actually a minus. You're still going to get negative 2 times negative 2 is positive 4. But for the middle, for the O and the I, right, 3x minus 2 and 3x minus 2. For the O and the I, you're going to get negative 6x and negative 6x again, which is negative 12x. So that is called perfect square trinomial, because the thing factors into just one factor squared. It doesn't have two different factors. It's the same factor twice. Perfect square trinomial. Again, you notice it's a quadratic trinomial. It looks like the first term is a square, and the last term looks like a square. So you assume that it's going to be that, and you can just check it by FOILing. It doesn't have to work. It could be that it's not. But if this is not a perfect square trinomial, then you would have to factor it like we did on the homework from last night. Because that number is not a 1, you would have to go through a process, right? 4 times 25 is 100. What are the factors of 100 that add up to 20? 10, right? So then you would say x minus 10 times x minus 10. Oh, sorry, it was a plus 10. X plus 10. And then what? Divide by the 4. Divide by the 4. Seems like I got something going on here. But that can be simplified, right? That is x plus 5 halves, x plus 5 halves. And then because we don't want to have fractions, we slide the 2. We slide the 2 here on both. 2x plus 5 times 2x plus 5. So, I mean, if you don't remember the formula for this, it's okay. You could factor it in a different way. Usually if it's a perfect square trinomial, when you do that, like a times c, 4 times 25, you get like big numbers. Bigger numbers than we would usually ask you to factor, unless it just happened to be this special pattern. Okay. So again, you could factor this using the formula, or you could factor it just by however else we learned how to factor something like that. Right? The a is 1. Right? So if you're going to use the formula, you say, well, that looks like a perfect square, and that looks like a perfect square, right? That's 2 squared. So maybe this is just 8 plus 2 squared. Right? Now, if you wanted to factor it the other way, since that's a 1, you would say, what are the factors of 4 that add up to 4? And you would say 2 and 2. 8 plus 2 times 8 plus 2. Okay, Mike? Okay, how about this one? What do we presume might be the factoring of this one? It's a s. 4s squared plus 4st plus t squared. So what is being squared in the first term? 2s. Right? And then what is being squared here? T squared. So what would we expect might be the factoring of this thing? 2s plus t squared. Done. Again, you could check it by foiling 2s plus t times 2s plus t. You know, if you checked it, 2s times 2s is 4s squared. 2s times t is 2st. T times 2s is 2st, so that's 4st. And t times t is t squared. Again, if you didn't factor it that way, you'd have to like go through the long divide and slide, or slide and divide, whatever you call it. What's that? Uh-huh. Yeah. Okay. Okay, quiet, please. Yeah. Okay. So far we've done, these are all the different kinds of factoring that we saw, but there's one more possibility, which is we could have combinations of things going on. And the combinations of things are always, there's the greatest common factor, but then when you take it out, there's still something else to do. Like, for example, in this problem, which is a solve, and everything's on one side, zero's on the other, you know, if I didn't try to simplify this, I would have to do the long kind of factoring. 2 times 24 is 48. What are the factors of 48 that add up to negative 16? But in the end, there is the greatest common factor between 2 squared and 16t and 24. What is it? There's a 2, right? So you can factor it out, right? If I factor out a 2, it looks like this. 2 times t squared minus 8t plus 12 equals 0. But now in factoring, if this was not an equation, I would have to keep the 2 there. But because this is an equation, I could actually divide both sides by 2. Right? In algebra, as long as you do the same thing to one side as you do the other, that's allowed. Right? What would happen if I divided by 2 on both sides? On the left, I would have t squared minus 8t plus 12. And then what is 0 divided by 2? It's still 0. So the truth is that if it's an equation, you don't really have to factor out the 2. You just divide out the 2. Just divide every term. That one, that one, that one, and that one by 2. And just lose the 2. Right? We don't need it. Okay, now that's something we should be able to factor. Right? This is the simple quadratic trinomial because it's got a 1 there. What are the factors of 12 that add up to negative 8? 6 and 2, but they add up to negative 8. So it should be minus 2, minus 6. Right? If they multiply to give you a positive 12 and they add to give you negative 8. Okay, and then what are the solutions? Remember, you're not done until you say what are the values of t? 2 and 6. Right? If it's just a simple, you know, t minus 2, you can imagine that 2 minus 2 makes a 0 and 6 minus 6 makes a 0. That's certainly the point you want to get to. How about this one? It's only the 2 terms, so is it a difference of squares? It's not. But is there a greatest common factor? It's 2. 2 is the biggest factor that goes into both of those, so we're going to take out a 2. Right? So now what's left inside if I factor out a 2? 9n squared minus 4. Right? So first I took out the greatest common factor, and now is that a difference of squares?
Yeah.
Yeah, I mean 9 and 4 are both perfect squares, so this thing should factor like a difference of squares. Right, so remember this is 2 times 3n in parentheses squared minus 2 squared. And by the formula, it should be 3n plus 2, 3n minus 2. Got it. So when it says combination, the combination is always, it's the greatest common factor, and then there's something else. It's usually a difference of squares or the simple quadratic trinomial. You got to be on the lookout for that. Let's try. Well, if I was just going to do this one. Solve by factoring. What is the greatest common factor you see there? I mean, you might think, Maybe it's 3. How can you tell? Does 3 go into 36? Okay, that one we probably know. How about, does it go into 108? How do you know by looking at the number if it does? You add up the digits, right? If 1 plus 0 plus 8 is divisible by 3, then so is 108. So 1 plus 8 is 9. Yes, this is divisible by 3. So we clearly, there's a greatest common factor of 3. We could divide it out, right? But there's also, because that's a negative 3, and we kind of like to start with a positive, why don't we just divide out negative 3? Why don't we divide every term by negative 3? Okay, the first term then becomes a positive y squared. What's 36 over negative 3? Minus 12y. What's 108, negative 108 over negative 3? Calculator time. 36, so plus 36 equals 0. Okay, so what are the factors of 36 that add up to negative 12? Factors of 36 that add up to negative 12. Negative 6, negative 6. Y minus 6 squared. Equals 0. Okay, now what are the solutions? What do you plug in for y there to make a 0? 6. Right? And that is the only solution, because there's only one factor and it was being squared. So usually quadratics have 2 answers, but if it's actually a perfect square trinomial, which that one was, then you just get 1. And we'll see later, I think next class, you'll see that sometimes you can get 0 answers. Yeah. The perfect square, yeah, we could have used the kind of factoring from earlier. If you would have noticed that that's a perfect square and that's a perfect square, you might have said, oh, you know what, this is probably just y minus 6 squared. But if you don't remember that formula, it's just as easy to just, do the simple, what are the factors of 36 that add up to negative 12? Right. So try to factor that one. Factor out of 2. What's left in parentheses if I factor out of 2? Okay, and it's not an equation, so you can't lose the 2. Like in an equation, you could lose the 2 because you could just divide both sides by that number. 0 divided by anything is 0 anyways. Here you got to keep the 2. Okay, now what kind of factoring would we do on what's left in parentheses? I mean, it's really like the last one. You could think of it like the perfect square trinomial. I mean, the first term is something squared. The last thing is something squared, right? So that is y, and because that's a negative, minus 5 squared. Keep the 2. Now, does that work? I mean, the other way to do it is you could just think of it like, what are the factors of 25 that add up to negative 10? Negative 5, negative 5. Done. But don't lose the 2, right? Don't lose the 2. If this was all set equal to 0, then you could lose the 2. But you have to keep it in that case. Alrighty. So that is homework.